Hello, students. Welcome back. So, in this session, I'm going to show you the famous empirical rule. The rule is associated with these numbers 68, 95, 99.7. I'll explain you what these numbers they mean. Empirical rule essentially they describe how your data is distributed in your normal distribution. Another name for normal distribution is your Gaussian distribution. That's another name for that. These distributions generally they do have a bell-shaped curve like this right here. This is your bell-shaped curve. This rule is devised by nature and it seems like it is almost universally true in any data that you look at it. The rule essentially says this that approximately that about 68% of your data it lies within one standard deviation of the mean. In other words, if let's say this is your mean value, right? This is your mean value, then if you go one standard deviation in this direction, which will be mu minus sigma over here, and if you go one standard deviation in this direction, okay, this would be mu plus sigma, then 68% of your data is going to lie in this range. That's what this rule says. 68% of your data is going to be lying over here. About 95% of your data, okay, it lies within two standard deviation of your mean. In other words, 95% of your data it lies between mu minus 2 sigma and mu plus 2 sigma. So if you go in this direction, okay, you go 2 sigma in this direction and you go 2 sigma in this direction, then approximately 95% of your data is going to be lying over there. About 99.7% of your data lies within three standard deviation of the mean. Well, what it means is this that approximately 99.7% of your data lies between mu minus 3 sigma and mu plus 3 sigma. In other words, if you go, let's say this is your mean value, and if you go 3 in this direction, 3 standard deviation in this direction, and 3 standard deviation in this direction, okay, so approximately 99, this 99.7% of your data would be in between mu minus 3 sigma and mu plus 3 sigma. Now, one of the characteristics of this curve is that it is symmetrical. This normal distribution curve is symmetrical in nature. What it means is this, that the curve on your left-hand side of the mean, this part, is the mirror copy of the curve on your right-hand side of the mean. Okay, they are exactly same. So what does it mean? What exactly it implies? How can we use this information to our advantage? Well, look at this right here. I know 68% of my data, according to the empirical rule, 68% of my data lies between mu minus sigma and mu plus sigma. And I also know that my curve is symmetrical about mean. So that means this right here, okay, this part is going to contain 68, right? 68 divided by 2 equal to 34% of my data. So this will contain 34% of my data. And this right here is going to contain the other half, which is 34% of my data. And that's what this statement means, that 34% of my data lies between mu minus sigma, which is right here, and mu right here, which is this right here. Okay, now let's look at this statement. What does this statement means? Now, if you look over here, you can see that 68% of my data lies in this region, right? And then 95% of my data lies in this region right here. So what's left over? If you take away 95 minus 68, you will be left over with these numbers, right? Numbers in this region. Now, this one will be 95 minus 68. Now, each one of the regions is symmetrical. You know the curve is symmetrical, so that means the amount of data in this area, in this region, and the amount of data in this region are exactly same. So you divide it by 2, and your answer would be 13.5. That means 13.5% of my data would be lying in this region. Likewise, this region will contain 13.5% of my data. Okay. 13.5%. And that's what this other statement means. Likewise, you can derive this one too, 2.35. This will contain 2.35% of my data. So the amount of data between mu minus 3 sigma and mu minus 2 sigma is 2.35. And the amount of data between mu plus 2 sigma and mu plus 3 sigma is 2.35. You can similarly derive these conclusions. So let's try to understand this empirical rule through an example. So let's say you have a data, and your data is exam scores of students from all schools, and you know that your data is normally distributed. By the way, empirical rule only works, it only holds if your data is normally distributed. If it's not going to work. So this is an essential condition of your normal. of your empirical rule. Okay, your mean, let's say, is 70, that's given to you, and your standard deviation is 10, that's provided to you. So, what does it mean? Well, according to your empirical rule, it says that 68% of your data, okay, 68% of your data lies between mu minus sigma and mu plus sigma. So, 68% of your student, they scored between mu minus sigma and mu plus sigma. Well, substitute your value of mu, which is 70, right? Substitute your value of sigma, which is 10, okay, and the answer would be 60 and 10. So in other words, 68% of your student, they scored between 60 and 10. So 68% of your students, right here, this one, they scored between 60, right, 60 over here, and 80 right there. So between 60 and 80, that's the 68% of your student, they scored between 60 and 80. Okay, the other one is 95%. So you know 95% of your data is going to lie between mu minus 2 sigma and mu plus 2 sigma. So substitute your value of mu, substitute your value of sigma, and their answer will come out to be that 95% of your student, they scored between 50 and 90. So 95% of your student right here, this is your 95% of your student, they scored between 50, all right, and 90 right here. Likewise, 99% of your data, 99.7% of your data, that's between mu minus 3 sigma and mu plus 3 sigma. That means 99.7% of your student, okay, they scored between 40 and 100. So this is my 40 right here, and this is my 100. Okay, so 99.7% of my students, they scored between 40 and 100. Let's say somebody gives you this problem. They say that the height of adult men, okay, in a city is normally distributed. They tell you that. And they also tell you that the mean height is 175 centimeter and that the standard deviation is 5 centimeter. They want you to find, using empirical rule, they want you to find the range around the mean that would include 68% of men height. Also, using empirical rule, they want you to determine the range around the mean that would include 95% of the men height. Okay, let's get started. You have number one. Well, we know according to our empirical rule that 68% of your data is going to lie between mu minus sigma and mu plus sigma. Substitute your value of mu. Okay, my mu is 175, right? Substitute your value of sigma. This is 5. So 68% of the men's height is going to be in between 170 and 180 centimeter. So right here, okay, this is my 68% of my data right here. This is my 68%. So that 68% data will be between 170, okay, 170 and 180 centimeter. All right, now let's look at the second one. Same thing. My empirical rule says that 95%, okay, my 95% of my data is between mu minus 2 sigma and mu plus 2 sigma. Substitute your value of mu, substitute your value of sigma in there, and you'll come up with the answer as 165 and 185 centimeters. That means 95% of the men's height, right here, 95% of the men's height is going to be between 165, okay, and 185 centimeter. Suppose that the heights of adult men in a city is normally distributed. Okay, that's given to you, and also given to you that the mean value is 175 centimeter and standard deviation of 5 centimeter. Now, using empirical rule, your task is to determine the percentage of people whose height is between 175 and 180 centimeter, and you have to find the percentage of people whose height is between 170 and 185 centimeters. So you have to use empirical rule. Okay, so let's start with the question number one. I know through my empirical rule that 68% of my data, 68% of my data right here, it lies between mu minus sigma and mu plus sigma. Well, substitute your value of mu and sigma. So my mu minus sigma will become 170 right here. This is my mu minus sigma, 170. My mu is 175, okay? And mu plus sigma will become 180. All right, so I know 68% of my data right here. This is my 68% of my data right here. Okay, but I have to find 170, this one right here. I have to find between 175 and 180. So this will be 34%. So 34% of my data is between 175 and 180. So the answer is 34%. Okay, that's the answer for the first one. Second one, they want you to find the percentage of people, okay, whose height is between 170 centimeter and 185 centimeter. Well, coming back over here, where exactly your 185 centimeter going to be? Well, right there is 180. 185 is right here. Mu plus 2 sigma. Okay, this is my 185. Mu plus 2 sigma is 185. So you have to find the percentage of people whose height is between right here 170 all the way up to 185, which is right here. So you have to find the percentage of people in this range right here. Well, you know this one, okay, from here to here. This is 68%, right? This is 68%. And this right here from here to here is 13.5%. Just add them together. Okay. And the answer would be 68% plus 13.5% equal to 81.5%. So 81.5% of the people, their height is between 170 and 185 centimeter.